Teams A, B, and C are playing a game of strength. Each team has attached a rope to a metal ring and is trying to pull the ring into their own area. Team area is shown below. So let's see what that's. So we see that over here. Team A is pulling on the ring in that direction. Team B is pulling on the ring in that direction. Team C is pulling on the ring in that direction. They're each trying to get the ring into their respective areas. It's a three-way tug of war. They tell us Team A pulls with the force vector A of 4 times the unit vector I plus 0j. So this is 4 times. There's no vertical component here. So it's going straight in the positive, I guess you could say, x direction. And we can see it right over there. A is going straight in the positive x direction. It's just a multiple of the unit vector I. Team B pulls with force vector negative 2i plus 4j. So it's to the left and up. And we see that negative 2i plus 4j. Then we have Team C pulls with a force vector negative 3i minus 3j. So let's see. Negative 3i minus 3j. Yep, that seems consistent with the diagram. Forces are given in kilonewtons. All right. Which team will win the game? So to think about which team will win the game, we have to think about which one is pulling with the most magnitude in their direction. So let me get my little scratch pad out. And let's think about the magnitudes of each of these vectors. So let's first think about the magnitude of vector A. What is that going to be? Well, it's 4 times the unit vector I. It's just going to have a magnitude of 4. The unit vector I has a magnitude of 1, so its magnitude is just 4 times that. Its magnitude is equal to 4, and let's put the units there. It's 4 kilonewtons. Now, what about the magnitude of vector B? The magnitude of vector B, well, we can use the Pythagorean theorem. It's negative 2i plus 4j. So the magnitude squared is going to be negative 2 squared plus 4 squared, which is really just coming out of the Pythagorean theorem. So the magnitude of vector B is going to be equal to the square root of negative 2 squared plus 4, or one way to think about it, this is the Pythagorean theorem or the distance formula between the origin and that point right over there, plus 4 squared, that's 4 plus 16. This is the square root of 20. And let's see, this is definitely greater than 4. 4 squared is just 16. This is someplace between 4 and 5. And let's see, Team C, the magnitude of vector C, same logic, is going to be the square root of negative 3 squared plus negative 3 squared, which is equal to, let's see, this is the square root of 18. Right, 9 plus 9, square root of 18. So square root of 20 is clearly larger than square root of 18, and we already said that square root of 20 is larger than 4. So Team B is going to win. Which team will win the game? Team B. And we can even, let's just fill it out on our Team B is going to win the game. Now, the next thing they ask us is what is the magnitude of the team's combined forces acting on the ring? Well, to figure that out, we can just add up all of these vectors. The combined force, so let's write this. So the force, let's say force combined, this is a vector. It's going to be the sum of vectors A plus vector B plus C, which is going to be equal to 4i plus 0j plus or minus 2i plus 4j minus 3i minus 3j. And so now we can just add up the i's and add up the j's. So we have 4i minus 2i minus 3i. So 4 of something minus 2, you're going to have 2 left. Then you subtract another 3, you're going to have negative 1 of that. So that's going to be equal to negative, I could write negative 1i or just negative I. And then we have 0j's plus 4j's minus 3j's. So that's 0 plus 4 minus 3 is just going to be 1j. Or you could say just plus j. So that's the resulting vector here is negative I plus j. So it might look something like this. So negative I plus a j gets us a vector gets us a vector that looks like that. And let me actually draw it a little bit bigger here. So if I were to draw our coordinate axes, it's my y-axis. This is my x-axis. It's -1 times I. So let's say it looks like that. That's negative I. That's negative I right over there. Negative I. Let me write that. That is negative I plus j. Plus the j unit vector, which might look something like this. Both of them have a magnitude of 1, so that is the j unit vector. And the sum of those two is our combined force. Our combined force is going to be going into this direction. So, and this is its magnitude. So the length of it is its magnitude, combined force. And that goes in line with, we're going to be going in that direction, which takes us to the zone of B. But they ask us, what is the magnitude of the team's combined force? Well, the magnitude of this side is 1. It's a unit vector where it's going in the left direction. The magnitude of this side is 1. So the magnitude of this side, we just use the Pythagorean theorem. It's the square root of 1 squared plus 1 squared, which is just the square root of 2. So the magnitude here, what is the magnitude of the team's combined forces? Is square root of 2. In what direction is the ring getting pulled? And actually, let me just fill out what they've already asked us, just so we can. So what is the magnitude of the team's combined force acting on the ring? Round to the nearest tenth. So let's just write square root of 2. Square root of 2 is equal to, and round to the nearest tenth, 1.4 kilonewtons. 1.4 kilonewtons. And in what direction is the ring getting pulled? And they want us in radians, round to the nearest tenth. Your answer should be between 0 and 2 pi radians. So that, go back to our diagram, we need to figure out what this angle is right over here. We need to figure out what that angle is in radians. And we know that this whole thing, if we went from the positive x-axis all the way to the negative x-axis, that is pi radians. And we also know what this angle right over here is. How do we know that? Well, I've just constructed notice this is a right angle, and this is an isosceles triangle. Isosceles right triangle. It's going to be a 45, 90 triangle. But if you're thinking in terms of radians, 45 degrees is pi over 4. So this is pi over 4, pi over 4, pi over 2 triangle. Same thing as 45, 90. So if this whole purple angle is pi, and this is pi over 4, you just subtract the pi over 4 from the pi to get what theta is. So theta is going to be equal to, pi is the same thing as 4 pi over 4, minus pi over 4, minus pi over 4. I just did that to get a common denominator, which is equal to 3 pi over 4. 3 pi over 4 radians. So let's go back over here. Now they want us to round it to the nearest tenth. So let's take 3 times pi divided by, actually make sure you can see what I'm doing here. So 3 times pi divided by 4 is equal to 2.356, round to the nearest tenth would be 2.4 radians. So approximately 2.4 radians, and we got it right.